Okay, in this video we're going to talk about Unit 1, Objective 1, average rate of change. So the definition would be the amount of function changes divided by the time it takes to make that change is going to be called the average rate of change of the function. Now, we're going to call the function the y values and the time the x values. Sometimes it'll be t values, but it's basically change in y over change in x. So basically what we're looking at with the average rate of change is the slope of a secant line connecting 2 points on the function. So if we have, let's just say, some random function, and we take 2 points on said function, and we connect the points with a secant line, the slope of that secant line is going to be the average rate of change of that function over this interval from, let's call it a to b. So however much the y value changes over this time interval, we're going to call the average rate of change. So that's just slope like we've been talking about it since Algebra 1. Slope's going to play a very important role in calculus, mostly the meaning of the slope. So let's kind of take a look at this problem here, and we'll talk about how we're going to find the meaning and use the units to explain the meaning. So 23 days into an experiment, a population of fruit flies is 150. 45 days into the experiment, the population is 340. Find the average rate of change between the two data points and, using correct units, explain its meaning in the context of the problem. So looking through here, we can kind of see that we have 2 points. We have the point 23, 150. And we have the other data point 45, 340. Sorry, I'm trying to get used to this new tablet I have. So 45, 340. To find the average rate of change, we're just going to find the slope between those 2 points. So we'll say 340 minus 150 divided by 45 minus 23. And technically speaking, this will be the first time I get to say this to you in this class, you can stop there. The AP exam does not require you to simplify anything. As long as your answer is going to be algebraically equivalent, you can stop. So technically speaking, numerically, we're finished with this problem. Now I'm going to go ahead and simplify it a little bit. This is going to be approximately equal to 8.636. So another thing that this will be the first time I get to tell you this, in calculus we're going to round to 3 decimal places. So we don't have to simplify, and we have to round to 3 decimal places. So numerically, there's our answer. We found the average rate of change, but the problem also says, using correct units, explain the meaning in the context of the problem. So what we're going to say is, first let's find the units, right? Using correct units. So when we have a rate, this is something I didn't put on the guided notes page, but you might want to make a little note of this somewhere. When we have a rate, we want to divide our units. Wow, this tablet's not good. Divide our units. Now, the division is going to be really, really easy to think about because we're looking at a division problem right here. So we think about the top. What are the units of the top? Well, the unit is flies, right? 150 fruit flies, 340 fruit flies, so we're going to say flies. And the units for our denominator is going to be days, so flies per day. So we still haven't really said the meaning, but we now have our units, 8.636 flies per day. So the meaning is going to be the population was increasing And this idea of increasing we'll talk a lot about in a later unit. But the population was increasing an average of, and we have to say average because we found the average rate of change. So an average, and I apologize for my handwriting. I'm trying to get used to this new tablet I have. So an average of 8.636 flies per day It's not letting me make that E. There we go. Flies per day on the interval 23 to 45. So there's certain things that AP is going to be looking for when they look at an explanation. So you're going to need to say the numeric answer. You're going to need to say the units. You're going to need to say if the population was increasing or decreasing. And you're also going to need to give the time interval over which this happened. If any of those things are not present in your sentence, you don't get the point. So population was increasing on average of 636 flies per day on the interval 23 to 45. So there's one other thing we want to talk about as far as average rate of change. They're generally used to estimate the slope of a tangent line, which are the ones that are really, really important for calculus. However, they can also be used to find a normal line, and a normal line is a line that's perpendicular to a function. So if we look at, say, another just random function, in calculus, again, one of the biggest things that we're going to be looking for is slopes of tangent lines. So if I have a point right there, we're eventually going to be really, really curious about that slope right there. Remember that a tangent line intersects a function at exactly one point. And then a normal line would be the line that's perpendicular to that tangent line. So if we can use average rates of change to estimate the slope of the tangent line, we can also use average rates of change to find the slope of the normal line. So let's look at an example, and then we will finish up this video. So use the secant line passing through the function f of x equals 4 minus x squared when x equals 1 and x equals 2 to estimate the line normal to f of x when x equals 1. Alright, so to give us an idea of kind of what we're doing, let's take a look, just a quick sketch of what this thing looks like. You should know what 4 minus x squared looks like. It's a parabola that opens down, or we're going to say it's concave down, that has a y-intercept of 4 and x-intercepts of plus and minus 2. And I missed, but you guys get the point. So what we're trying to do in this problem is we're trying to find the secant line that goes through these 2 points to estimate the tangent line that just goes through the point here where x equals 1. So they kind of look similar because my picture is not very good. But the light blue line's going through just x equals 1. The red line is going through both points. Now they're going to be close because the points that we have on my secant line are pretty close to each other, right? The closer I'm going to put these 2 points on the secant line, the closer it's going to get to this tangent line. If I were to take this point here and kind of scoot it closer, I'm going to get closer and closer to that blue tangent line. But we're going to try to use that to come up with the slope of the line that's perpendicular. So we're going to try to come up with that line there. So what we're going to need, if we're trying to come up with the equation of a line, actually I'm not asked to do that. We're just trying to find the slope, estimate the line normal. Line, sorry. This wants the equation of a line. If we're going to try to find the equation of a line, we need a point and we need a slope. So we know a point is going to be 1 comma something. Right? They're telling us we want the secant line or the normal line that goes through this point here. So all we're going to need to do, we know that this normal line is going to intersect the function at that point. So we plug 1 in here. 4 minus 1 squared is going to give us 3. And we need the slope. Well, the slope's going to come from the opposite reciprocal of the secant line. The secant line has the points 1 comma 3 and 2. If we plug 2 in, 2 squared is 4, so we get 2 comma 0. So we need to find the slope of this. That's going to give us the secant line. So let's go 0 minus 3 over 2 minus 1. That's going to give us a slope of negative 3. Which means the slope of the normal line, so it's perpendicular, so the slope of the normal line is going to be positive 1/3. So this pink line here is approximately going to be y minus 3 equals 1/3 x minus 1. So in calculus, we're going to want to use point-slope form as much as possible. If you want to use your slope-intercept form, you're free to, but point-slope form is going to be easier, especially since we don't have to simplify. So normal line is basically just a perpendicular line, and then we will call it quits on this video right there. See you in the next one.